So a bar is subjected to the two equal forces. Pushing the bar is shown. Okay. Now it causes shortening of the bar. Such forces which are causing shortening or contracting or compressive. So that are known as compressive forces and corresponding to stresses are compressive stresses. Last one I have already discussed you. Simple is a force applied on the body, compressive force. In that manner, this is the compressive force. Okay. Here applied the compressive forces. Means this is shorten the body. Means the body is bulging in that manner. Okay. Okay. This is a we will discuss in the stress and this concept in the column and stress. Okay. Means compressive force applied. Then here bulging are obtained. Means shape are changed. Base shapes are bulged. So this is the concept of column and stress. We will discuss in the next article. So now in similar fashion, in that case also you should take the forces. Suppose you're cutting the plane. Suppose here passing the plane here. Suppose here pass the cutting plane. So this is the cutting plane. Okay, or section plane. So after cutting this portion, you suppose this is the one portion or two portion. This is there one portion. So we consider only one portion. So here this is the press force, axial force applied, and here a resisting force. Resistance force means compressive resistance force applied on this body. So it should be balanced, means equilibrium. This force in that direction, this force also in that direction. So resisting force uniformly acting on that surface. Okay. Now remaining surface here. This is the suppose number two. Here forces acting on the suppose here P, and this is the component number two. Here forces, these are the resistance forces. Okay, these are the resistance forces acting. So here this is also a resistance force. Okay, so compressive force. So R basically now for equilibrium condition R is equal to P, but R is equal to sigma into area. Okay, this is equal to P. But number of forces, so here you can integrate. R is equal to basically R is equal to simple meaning sigma dA. So after integrating the whole component, so R is equal to obtained sigma is a constant here. The area is variable here. So after integrating, we obtain R is equal to sigma into area. Okay. So here obtained as in that cases. Okay. So stress assumed uniform. Assumption have taken, but is not the condition. It is assumption that stress is uniform acting on the cross-sectional bar. So for equilibrium condition, we have already applied this case. So whether it is tensile or compressive, so stress developed in the bar subjected to axial forces is equal to load per unit area. Okay. But if normal force, normal load per unit area, that is called pressure. It should you remember question in the interview asking they ask what is the difference between pressure and stress. So your answer should be is that normal force or normal load per unit area, that is called pressure. If the pressure is equal to Fn, normal force upon area. Okay, means this is the normal force. Okay, normal force. Okay, so this is the normal force upon area. So means pressure means normal force means perpendicular force means force should be perpendicular either in this direction, either in this direction. either in the direction. If in the direction, then this taken. If that direction, that this taken. Okay. So see, normal force is perpendicular. Suppose this is the plane, this is the force. This is the force, not Fn here. This is the Fn here. Now in that case, here Fn here. This is the Fn here. Okay. So normal force per unit area is called pressure, and sigma basically means stress is equal to force per unit original cross-sectional area. That is called stress or engineering stress or conventional stress.